Euclid's ninth proposition says that given an angle, we should be able to divide or bifurcate this angle into two equal angles. So let's see how we can do that. Just for reference purpose, I'll mark 2 points so that I can refer to line AB and line AC. Okay. And the first thing that I do is draw a circle with center as A and any radius. It doesn't matter what the radius is. What we are interested in is these two intersection points. Mark a point D and E. And now that I have D and E, I don't really require B and C for reference purpose. Now let's connect D and E. And now, keeping D as the center, let's draw a circle of radius DE, and keeping the center at E, let's draw a circle of radius DE again. So now we get a point of intersection. So let's mark the point of intersection F. And now let's join this A and F. Now, what the proposition says is that this line will cut this angle into two equal parts. Now, to prove that, let's join D and F, and let's connect E and F. Okay, now that we have got the points of intersections, we don't really require these circles. So let's simplify the diagram by removing these circles. Okay, so now how do we prove that angle DAF is equal to angle FAE? Can we use these two triangles? Not really, because we don't know that these two angles are equal, which is what we have to prove. We know that AD is equal to AE because it is the radius of the same circle. Okay, so we know these two are equal. This is common side, but we don't know that these two are equal. One other thing that we know is that this angle is equal to this angle because the sides are equal, so opposite angles will be equal. So we have side angle. The angle is not in between these two equal sides. So we can't really use our existing knowledge or existing propositions to prove that these two triangles are congruent. So let's look at a triangle ADF or DAF and FAE. Now here what can we say? If you notice, AD is equal to AE. So let me just highlight the triangle so that it becomes easier for us to, these two triangles we are talking about. So here AD is equal to AE, radii of the same circle. We know DF is equal to EF because again radii of circles with the same radius. And what else do we know? That this side is common to both the triangles. So side, proposition we can use here to say that this triangle is congruent to this triangle. Now, once we are able to say that, that means what? The corresponding angles are also going to be equal. So that means that this angle DAF is equal to FAE. So that is how we cut a angle into two equal angles. Again, I have provided a link to a PDF book in the description of the video where I describe 48 propositions in the first book of Euclid's Elements. Please feel free to download and go through it. That's it for now.